Torsion and detorsion in gastropods. Torsion in gastropoda. All the living molluscs except the gastropoda retain the ancestral bilateral symmetry of the body, with the mantle cavity lying posteriorly or laterally. The gastropods, on the other hand, possess an asymmetrical body with the mantle cavity lying anteriorly and the shell and the visceral mass coiled spirally and directed posteriorly. In spite of their asymmetry, gastropoda are generally believed to have descended from an unsegmented and bilaterally symmetrical ancestor with a low conical shell. A straight alimentary canal ending in a posterior anus and the mantle cavity posterior, that is, lying behind the visceral dome. The anterior situation of the mantle cavity in the gastropods is due to torsion or twisting of the visceral mass during development. Torsion or twisting is a process during larva development of gastropods, which rotates the viscera pallium anti-clockwise through 180 degree from its initial position, so that the mantle cavity with its pallial complex is brought to the front of the body in the adult. Torsion has played the most important role in the evolutionary history of the gastropoda. Torsion versus coiling. Torsion is often confused with the spiral coiling of the visceral mass and shell, but the two are entirely distinct and quite independent. Torsion is not coiling of the shell, which evolved even before torsion. Coiling of the shell in a compact spiral ensures protection, concentration, strength, reduced diameter, better balance, and a provision for continuous growth. Two types of coiling is met within gastropoda. Fossil evidence shows that the pre-torsion cell is early gastropods was planospiral, that is, the shell was bilaterally symmetrical with each spiral completely outside the preceding one and in the same plane like a rubber tube lying coiled flat on the ground. Planospiral coiling suffered from many disadvantages: unwieldy shape, bilateral restriction of mantle cavity, sharp reduction in the diameter of inner coils with consequent reduction in available visceral space. Later, the gastropods evolved as a conispiral shell, that is an asymmetrical shell with helical coiling around a central axis, the columella, with each coil below the preceding one. Helical or conspiral coiling provides better balance to the visceral sac as it grows and solves sanitation problems brought about by torsion. Coiling is achieved by a more rapid growth of one side of the visceral mass than the other. Torsion and coiling are therefore separate evolutionary events. Torsion was a much more drastic event than the spiraling of the shell. How torsion occurs? Torsion is not merely an evolutionary hypothesis. Its occurrence can be seen in the embryogeny of the living gastropods. Before torsion, the larva is quite symmetrical. The mantle cavity faces backwards and downwards. The alimentary canal is straight and the anus opens posteriorly in the middle line. A ventral flexure of the body results in the looping of the alimentary canal and the approximation of mouth and anus. The shell and the visceral mass, originally saucer-shaped, become first cone-shaped and later spirally coiled. The shell lies dorsally and forms a coil on the anterior side. Such a shell is called exogastric. The ventral flexure is followed by a lateral torsion so that the dorsal or exogastric shell becomes ventral or endogastric. The lateral torsion is probably due to arrest of growth on one side and active extension on the other side. Generally, the growth of the right side becomes retarded so that the mantle cavity and the pallial complex gradually pass round to the right side, and so to the anterior side, on account of the greater growth of the visceral sac towards the left. But the whole process completes in 2 or 3 minutes in acmea, so that it cannot be regarded due to differential growth. On the contrary, it is due to muscular contractions. The actual mechanism of torsion is supposed to be asymmetrical position and pull of the larval retractor muscles running from the velar lobes of the shell. They are present only on the right side, there being no related muscles on the left side. The contraction of the larval retractor muscles brings about the rotation or torsion. Only the narrow neck of the larva is actually twisted. Consequently, everything between the head and anus undergoes an anti-clockwise rotation or torsion through an angle of 180 degree around a vertical axis passing in a dorso-ventrally direction. Effects of torsion. Torsion is a fundamental feature of gastropods and represents their greatest departure from the ancestral molluscan plan. The peculiarities of organization of gastropods due to torsion were first realized by Spengel. He also coined the term streptoneura and euthymura in relation to torsion. The effects of torsion are not equally evident in all gastropods. Displacement of mantle cavity. The mantle cavity was primitively posterior in position. The increase in the length of the ventral foot, which primitively was very short, tends to remove the mantle cavity and the pallial complex away from the head. After torsion, the mantle cavity opens just behind the head and its associated parts are shifted forwards. Changes in relative positions. Before torsion, the anus, the tenidia and the renal orifices points backwards and the auricles lie behind the ventricles. After torsion, the anus, the tenidia and the renal orifices project forward and the auricles lie in front of the ventricles. Looping of alimentary canal, the digestive tract, which was originally straight from mouth to anus, is thrown into a loop. Cystoneury, the long uncoiled pleurovisceral nerve connectives twisted. The right connective with its ganglion passes over the intestine to become the supraintestinal, while the left connective passing underneath the intestine to become the infraintestinal. Endogastric coil, the coil of the visceral sac and the shell, which primitively was dorsal or exogastric, becomes ventral or endogastric after torsion. Loss of symmetry and atrophy. The anus is displaced toward the right side of the pallial cavity so that the original symmetry of the organization disappears. Another characteristic feature evolving asymmetry is the reduction or atrophy of the paired parts of the primitively left of topographically right side. In the primitive archaeogastropoda or diatocardia, example, patella, heliotis, Fissurella, etc. Maximum symmetry is preserved by retaining two gills, two auricles and two kidneys, but the right kidney serves as a gonoduct. In the more specialized Mesogastropoda or Monotocardia, example, Pila, Buckingham, Litornia, etc.,